go ahead and start this webinar. So welcome everybody to the webinar Expand Your Material Knowledge with Ansys Granta EduPack. It's a webinar of 1 hour, maybe a little bit less, and we are going to explain you more about what Granta EduPack can do. So if you are new to Granta EduPack, you will probably know a lot more by the end of this webinar. And if you are already Granta EduPack user, hopefully it will give you more insights of what more Granta EduPack can do than what you are doing with it at the moment. First, let me give you a short explanation on the GoToWebinar environment. As you can see, you can make the settings, let's say bar at the right side, you can make it bigger where you can view several settings for your audio and video. You will be muted the whole time during the webinar, but there will be the possibility to unmute yourself at the end of the webinar. There's also a questions pane where you can put your questions throughout the webinar, and at the end there will be a short Q&A session where we will go over several questions that we already received and ones that you may have during the time. I think that's all. Of course, this webinar will be recorded and everything will be sent to you afterwards, so you will be able to review it if necessary. So the webinar of today will be hosted by myself and my colleague Navid Manai. He's the Ansys Academic Development Manager, and he will be the go-to guy, let's say, regarding Granta EduPack, and we'll be explaining a lot more on all its functionalities and the resources surrounding it in the whole academic environment. Here is a short overview of the agenda where we will very fastly go into Granta EduPack. But first, I will give you a short introduction on, let's say, Infinite and Ansys, which will give more surrounding regarding Granta EduPack. So Infinite simulation systems has been in the Ansys business for over 35 years at the moment in the Benelux. So we are the official and only channel partner within the Benelux and serve over more than 750 customers today. Together with two other sister companies that work with PTC, that's software like Creo, CAD software, and PLM software. We have a very broad knowledge base and a lot of support engineers regarding everything in a certain workflow of product manufacturing and a lot of industries within the Benelux. Good to know is that we are indeed a solution partner. So we do not only provide software, we also provide services and we provide training. We'd like to think together with our customers, which can be also academics, to make sure that there is a certain implementation in a workflow. For academics, this means that we can help you with not only providing software like Granta EduPack, but we can also help you develop multiple workshops. We can also help you develop certain resources for students to engage in Ansys software and also PLM, CAD software, stuff like that. So it can be very broad, and that is the thing that we love most. Here is a short overview again of the services that we provide. So it's Ansys, and Ansys, I will explain a little bit more on what it is then specifically. Of course, we also give trainings. Also for academics, we have a lot of training possibilities. They can be very specific on Granta EduPack or on, let's say, the simulation tools, so on mechanical or the fluids dynamics. But that can all be altered based on, of course, the audience. We also have a support hotline, so we have several support engineers, all with their very experienced knowledge, all their specific expertise, that will help you throughout the usage of the software, of course. Our support also for academics is always available through email, through phone, to help you with, let's say, the practical side of the software. Now a little bit more about Ansys. So Ansys simulation process. So the process, meaning that Ansys has tools that can be used throughout the complete workflow of a certain company. So let's say commercially, when you have very specific things that you maybe manufacture, in every part of that workflow, Ansys can be used. We have several tools available where you can use it in the design stage, but also in the validation stage. This again proves that we are a solution partner, and we would like to think with you how you can optimize that certain workflow. For academics, of course, this means that we provide you with the right tools, let's say, but we also like to think together with you on how those tools can not only be used in one specific course regarding maybe materials, but can also be used in manufacturing and engineering, and where you can have the link between, let's say, Granta EduPack for materials, but also an Ansys Mechanical for structural analysis, because both of the tools can communicate together, and you can benefit, of course, the complete deal of all the Ansys tools. When looking at the broad portfolio of Ansys, you will see that in the top there are some yellow blocks, which indicate, let's say, the main physics that Ansys has, or where Ansys provides tools in. I think the more known physics are, of course, the fluids for aerodynamics, but also internal fluids in pumps and turbines. We have then the structures, which I think most known, of course, for mechanical analysis, but also crash dynamics, stuff like that. But it goes even further towards electromagnetic simulation, even semiconductor power simulations, and a lot more than that. Then we will talk more, of course, about the very big gray beam below it, materials information, meaning that since 2019, Ansys acquired Granta, and therefore also Granta EduPack, and has provided Granta EduPack and Granta in general to be linked also towards all the Ansys tools. Granta EduPack, and then let's say the research or commercial side of it, Granta Selector, are still standalone tools, which provide you with a lot of information regarding material data sets, but they are completely integrated also with Ansys tools. So during your simulations, you can also use the right and the correct properties of a certain material within your simulation. Then we also have a certain platform, which is called Ansys Workbench. It's, let's say, an environment which links all your simulations and your material information towards each other. So you have everything in one specific environment, and you have one specific project that you can share, that you can work on. But, oh yeah, what I also wanted to say regarding this, we have, of course, a lot of tools available, but they are also available, let's say, in an academic license environment. So Granta EduPack is a very specific package that is designed for academic instances, but also within the Ansys tools, we have several academic licenses available. So don't think that Ansys is only something that is used by bigger industries. Everything can be used also in academic instances in your curriculum very broadly. So at the end, when we will talk about our contact details, please feel free to ask questions on how you can benefit from the Ansys tools and not only, let's say, one part. It can be very broad. That was shortly everything regarding Infinite and Ansys, but let's go further, of course, to Granta EduPack. Think, Navid, I'm gonna make you the presenter. Yes. Think you can share your screen.
Yes. Thank you very much, Sarah. Can you confirm that you can see my screen?
Yes, of course. I can see it good.
Perfect. Thank you, Sarah, for the kind introductions. And good morning, everyone. Thank you for joining us within this session in which we are going to explore how Granta EduPack can help and support you in teaching materials-related topics. My name is Dr. Navid Manai. As Sarah mentioned, I'm part of the Ansys academic development team. So for today, we are going to explore Granta EduPack. Before getting into the slides that we've prepared for today, I wanted to mention that I might be coughing a little bit. So apologies for that. I'll try to mute myself if that happens. Okay, so before getting into the meat of the webinar, I wanted to say a few words about where the solutions that we are talking about have actually come from. So the Ansys Granta academic products. So in 1994, Professor Mike Ashby and his colleagues started the Granta Design Company out of University of Cambridge. The goal was to commercialize a material selection teaching project. During the years, we've had partnerships with different organizations such as ASM International, and in 2019, we became part of Ansys, the global leader in engineering simulation. And our vision has always been to integrate materials intelligence throughout education, research and development, and the product lifecycle. So at the moment, Ansys has three different products and solutions to cater for the need for materials data and information management. On the academic side, we have Granta EduPack and Granta Selector, which are being used for teaching and research purposes. And you can see a list of universities that have integrated these solutions in their curriculum. And on the industrial side, the Granta Selector is being used as the industrial standard for material selection, and Granta MI serves as the platform for information management for materials. And you can see some of the companies that have integrated these solutions in their workflow as well. So EduPack is currently being used in more than 1,400 educational institutions across the world, and we try to help academics in building their students' materials intelligence. So what is Granta EduPack? If you're not familiar with it, well, it's a unique educational software that provides comprehensive access to an encyclopedia of materials data and processes data, as well as powerful visualization, selection, and estimation tools in order to interrogate this data. But with this software, academics would also get access to more than 200 teaching and learning resources that are available on our website. These include lecture units, case studies, micro projects and exercises, and they help essentially to introduce materials and materials related topics to students using the Granta EduPack software. So in the beginning, we are going to focus on the software part, and by the end, I'm going to say a few words about the teaching resources as well. So how is the data actually structured within the software? So as you can see, there are three levels of databases, and going from level 1 to level 3, essentially the number of materials that we provide data sheets and information for increases, and also the specificity of information increases as well. So if we get one data sheet in level 1 that explains information about aluminium alloys, in level 2 we would have 3 data sheets regarding 3 types of aluminium alloys, and in level 3 we have more than 300 data sheets discussing information about specific grades of aluminium alloys. So this is why it would make sense, depending on the type of course and students that you're dealing with. Level 1 could be used for introductory courses, and then level 2 for intermediate ones, and level 3 for more advanced courses or capstone design projects that students would like to work on. As you can see, level 3, there are more than 4,000 materials that we have information for. This is on par with our industrial solutions Granta selector, which Sarah mentioned as well. Apologies. Yes, so Granta EduPack has 2 different editions. On the screen, you can see the data and tools that are available in the introductory edition. As you can see, most of these databases are level 1 and level 2 databases, but you do also have access to one level 3 database as well within the introductory edition. Depending on the type of and the subject of the course that you're teaching, you can pick and choose whichever of these databases would be more relevant for that specific course. So we have, as you can see, subject-specific course databases for sustainability, bioengineering, architecture. You can teach the fundamentals of material science with the elements database and the material science and engineering database. And the medical devices and the design database are product-centric databases. So you can cover the role of materials and processes in the product design or industrial design, for example, using these databases. On the tools side of things, we have the core functionalities of EduPack available. So students would be able to locate data within the structure of the database. With these tools, they can create visual charts and run material selection projects. They can investigate the environmental impact of products in their life cycle, and they can, of course, export this data to be used in any simulation or CAD software that they are working in as the material library. So that can be achieved as well. On the full edition of EduPack, apart from everything that we just talked about, you get some additional advanced databases and tools as well. So on the data side of things, as you can see, you would have access to 5 subject-specific advanced databases. These are level 3. In all of them, students would have access to temperature-dependent material properties as well as other curve data, such as magnetic pH curves, true plastic stress strain curves, fatigue strength curves, and so on. To give you an example, the aerospace database also includes the MMPDS handbook information, which is, as you know, the industrial standard for design allowables within the aerospace engineering industry. And with the polymer database and the links that it has to a wider handbook, students would have access to more than 100,000 grades of polymers. On the tools side of things, as you can see, there are a few tools that are only available in the full edition. To give you an example, with the synthesizer tool, students would be able to estimate the properties of hybrid structures. So these are numerical models for sandwich panels, multi-layer materials, cellular structures, composites, and students would be able to use these numerical models to estimate the properties of these hybrid structures. We're going to explore a little bit some of these tools when I jump into the software, and let me know if you want me to clarify anything, and we can do so in the Q&A session as well. By the way, if you have any questions, please put them in the questions part, and hopefully we can get to all of them by the end. So because of the breadth of the information that is available in EduPack, there are multiple departments that can benefit from and are now using EduPack, as you can see in this slide. And also it can be used throughout the years of the curriculum as well, because of the categorization of the databases that we just talked about. So there are many universities that are also using EduPack as a cross-campus resource. So multiple departments essentially using EduPack at the same time. Okay, so with that said, let's jump into the software, and I'll provide a demonstration of some of the data and tools and this typical structure of data sheets available in the software. This is the home screen of EduPack. So as you can see, we have the different levels and different types of databases available for us to choose from. Introductory ones on the left-hand side and the advanced databases on the right-hand side. For this demonstration, I will choose to use the level 2 database. So let's click on that. Apologies. Okay, so as you can see, this is the home screen of the level 2 database. In the middle of the home screen, we have the different categories of materials that we have data for within this level 2 database. On the right hand side, there are a few icons. For example, with the video tutorial icon, students would be able to be redirected to a set of short 5 to 6 minute videos with which they would be able to familiarize themselves with the general usage of some all of the functionalities of Granta EduPack. So it's a very good self-learning tool for students to start using the software. On the top, we have the main toolbar, which include all the different functionalities of EduPack. So for example, if students would like to locate data within the structure of the software, they can use the browse or the search functionalities. With the browse functionality, so let's imagine that we have a student that is interested in finding information about a specific material, such as nickel-based superalloys. Of course, they can use the browse or the search functionalities. With the browse button, as you can see, we have information for ceramics and glasses, hybrid materials, including composites and natural materials, for metallic alloys, and for polymers. So because our student is interested in nickel-based superalloys, of course, they would need to go into the category of metallics and metallic alloys and into the subcategory of non-ferrous alloys. And you can see we have a folder for nickel and alloys. So within here, we have a datasheet for nickel-based superalloys. If we click on it, the datasheet for this material pops up, which includes at the top images of the material, images of components that have been manufactured using this material. We have a brief description, which in this case states that nickel-based superalloys combine exceptional high temperature strength and excellent corrosion and oxidation resistance. It also mentions a few of the elements that actually provide these exceptional attributes to these materials. We have some information on the composition of the material, its density and price is available, mechanical properties including Young's modulus, yield strength, Poisson ratio. If students are not 100% sure on what some of these attributes are about, they can essentially click on the information icon next to each attribute and a science note pops up, which is a comprehensive source of information on the background, on this material attribute, how it can be measured or calculated, some of the other material attributes that are associated with Young's modulus. And at the bottom of the science note, we also have a list of further reading, which students can use in order to find more information about Young's modulus in any of these textbooks. So it's a very good self-learning resource for students to get more familiar with material attributes. Okay, so let's scroll further down. We have thermal properties of nickel-based superalloys, including melting point, thermoconductivity, specific heat capacity. We have the electrical and optical properties of the material. Criticality of the material is mentioned here, so whether it's going to have some supply chain issues at present or in the near future is identified here. How well the material can be processed using different processes is mentioned. How well the material would be able to withstand different environments. So as you can see, we have durability information for many different environments. Okay, and we also have some eco attributes of the material, including embodied energy and the CO2 footprint of the primary production and processing of the material is available. And by the end, we have some end-of-life attributes of the material as well. So whether it can be recycled or not, and if it can, what is the environmental impact of that recyclability is mentioned here. So we have some environmental notes, design guidelines, technical notes, the relevant corner of the phase diagram of nickel, titanium, and aluminium is mentioned in the nickel-based superalloy datasheet, and this is always available in level 2 databases. We also have typical uses of the material as well as the trade names that this material is available on the market with. So at the bottom of the datasheet, we also have links that students can use to find relevant information specifically for this material in the other parts of this database. So for example, if we use the Process Universe link, students can see all the different processes that are compatible for joining, shaping, and surface treating of this material. So as you can see, there are different subcategories for each of these. And if you go into, for example, the casting subcategory and into investment casting folder, you can see that we have one data sheet for investment casting. So each of these processes have their own dedicated data sheets. Let's open this one. So as you can see at the top of the data sheet for this process, we have the images of components that have been manufactured using this process, as well as the molds. We also have a description of the process as well as schematic of it. The materials and shapes that are compatible with this process are mentioned here. We have some information on the physical and quality attributes that can be expected. For example, the tolerance and the surface roughness that we can expect from components that are manufactured using this process. We have a cost model as well, which is a very good tool to essentially teach students about the economics of manufacturing. So as you can see, students would be able to manipulate and modify the values for parameters that are used within this model, and the software would let them know what would be the relative cost index per unit for manufacturing a component. So again, if if you want to teach about economics of manufacturing, this could be a very good tool for this. We also have design guidelines, technical notes, typical uses, environmental and economic notes for processes as well. Yeah, so that's essentially what I wanted to show you in terms of the typical structure of process and material data sheets in a level 2 database. And now we're going to move forward to the search functionality. Apologies. Okay. So what if students are interested in a material or a process or an application, and they're not easily able to find it within the tree structure in the browse section? Well, they can directly search for it, of course. So the search functionality is quite straightforward. It responds to most of the logical commands that are usually used with search engines like and, or, and so on. So let's search for example, a bicycle and see if we can find materials that would be relevant to this application. So if we search for bicycle, we can see that we have 6 materials that mention the term bicycle in their datasheet. So for example, if we open up the datasheet for wrought magnesium alloys, the datasheet for this material pops up. And if we scroll down, we can see that anywhere on this datasheet, which should be in the typical uses, the term bicycle is mentioned, it is highlighted. This is to help students to identify the relationship between the term that they have searched for and the datasheet that they have opened. So it makes it easier for them to understand why they are here. Okay, so that was, as mentioned, very straightforward, the search functionality. Let me clear some of these tabs. And I'm going to discuss the chart select functionality now. So as mentioned in the slides, there are capabilities in EduPack for creating visual charts and to run material selection. They are typically concentrated in this chart select functionality. So if we click on it, we can see that we are directly in a selection project. This is the same place that we can create visual charts as well. So in order to create a visual chart, we need to identify what it is that we are trying to essentially visualize. Is it materials? Is it processes? So as you can see, we can essentially choose to look into all the materials that are available in this database and compare them in terms of their attributes with this chart, or we can focus on a specific category of materials for this chart. So for our demo today, I'm going to be looking into all the materials that are available in this level 2 database, and you can see there is 100 of them. To create a chart, we can click on chart index. The software asks us to populate the Y and the X axis. I'm going to put stiffness and strength as two of the usual engineering attributes that are typically discussed with students. So on the Y axis, I'm going to have strength, which is a mechanical property, and this is yield strength. And on the x-axis, I'm going to put Young's modulus for stiffness. So that is, again, a mechanical property, and that is Young's modulus. You can see that we can use logarithmic scale or linear scale, and by pressing on OK, the visual chart pops up, Ashby chart, bubble chart. This has many names. And using this chart, we can essentially compare all of these different 100 materials in terms of their Young's modulus and yield strength. We can also visualize the different categories of materials that are available on this chart. So by clicking on Show Family Envelopes, we can click and drag to identify these family materials. So we have technical ceramics, metallic alloys, we have composites, non-technical ceramics, and polymers, foams and elastomers available on our chart. We can, of course, label individual materials as well. So you can see that we have tungsten alloys at the top right corner, and the flexible polymer foam on the bottom left corner of this chart. Apologies. Okay. So this is, of course, what you would be able to see in a level 2 database. Students can easily use this visual and interactive chart to compare materials in terms of their attributes or different categories of materials. But as you can see, the number is limited to 100 in this level 2 database. What would happen if we conduct the same charts but in a level 3 database? Well, we can easily test that. So let's just change our database to one of the level 3 databases, aerospace, for example, in this case. And I'm gonna keep everything that we've already done. So you get this chart in level 3. As you can see, the number of materials that are being essentially compared and visualized on this chart is much higher. There is more than 4,000 of them available here. This is why it would make sense probably to use level 3 databases for more advanced students to be able to handle this essentially higher level of specificity between the different grades of materials that are available in level 3 databases. Yes, so this is what the chart could look like. And of course, if we were running, material selection projects, there are a lot of different tools that would be available to us to focus on the most appropriate materials for a specific application that we're trying to find a material. These include some of the visual tools that are available. For example, if we are interested in a specific part of the chart, we have visual tools like the box selection here. We can, draw a box on the top right corner, and everything else that is not in the box would be eliminated. And then we can, remove them from the chart and focus on the materials that would be of interest to us because of that specific application that we would like to have high stiffness and high strength. So that is just one of the visual tools that is available to us. It of course depends on the design requirements that we are interested in. We can apply them using the different selection tools that are available in EduPack, for example, in the limit stage or in the tree stage. But because of the limitation in time, I won't be able to cover every tool. But some of the other functionalities of EduPack that I wanted to bring in at this point is, for example, the synthesizer tool. So let me just go back to the original charts. Okay, so the synthesizer tool, as I mentioned, helps students to estimate properties of hybrid structures. So as you can see, we have numerical models for cellular structures, composites, multi-layer materials, and sandwich panels. And using these models, students would be able to estimate properties. So to give you an example, let's use the numerical model for continuous fiber composite. And as you can see, the software asks us to identify the fiber orientation that is going to be used in this composite. One second, sorry. Apologies. I'm going to focus on, in this case, a quasi-isotropic orientation for our fiber in this composite. Then the students can identify the materials that are used for the matrix and the fiber. So let's choose, for example, a polypropylene for our matrix for this composite, which is, of course, a thermoplastic. So we can easily find polypropylene. There we go. As you can see, there are different grades of this material available for us to choose from. And I'm going to choose to use one of the unfilled versions because I want to fill it myself with fiber. And the fiber that I'm going to choose, there are many options available to us, but I'm going to choose one of the natural fibers that would, of course, improve the green credentials of this material. But for example, if we choose to use the hemp fiber, it also has good vibrational attributes as well. Then the students can choose what they would like to have as the fiber volume fraction within the composite. So as you can see, we can have a range and also we can identify the number of records that we want the software to create, which essentially means the number of materials within this range of fiber volume fraction that we would like to have information for. So then we can name the matrix and the fiber for this composite. And when we press on create, then we have our materials available within the browse section. As you can see, we have a new category called My Records, and we also have these materials available on our chart. You might not be able to easily see them now, so I'm going to remove the bubbles from the chart, the family bubbles, and then we can use this highlight synthesized records to essentially make these a bit more identifiable. So as you can see, we can of course click and drag to identify our synthesized materials. We can also click on these labels to go into the dedicated data sheets. So as you can see, within this synthesized materials datasheet, we have estimated properties for physical, mechanical, thermal, electrical, and eco attributes of the material is available to us. And then in the bottom, there are the choices that we made for the software to be able to create this datasheet and to estimate these properties. So that's essentially how the synthesizer tool works. It helps students estimate properties of hybrid structures, as mentioned. So if they are, for example, within projects that they are trying to design a component using hybrid structures, they can, in the early stages of design, get a good idea of what the properties of that material would look like before doing any physical testing or experimental testing using the synthesizer tool. Okay, so one last tool that we are going to explore is the engineering solver, and then we're going to go back to the slides and talk about the teaching resources. So with the engineering solver, students are able to convert essentially engineering requirements into material properties. For example, if the students are designing a component and they know the geometry, they know the loading condition for that component, but they're not sure what would be the, for example, Young's modulus or yield strength that they need to, keep in mind when they're trying to select the right materials for this application. So this is where the engineering solver can be helpful. So for example, if students are working on a project that has a panel embedding situation, they can choose this function, and then they would need to fill in some information about the geometry and the loading condition. For example, let's say this is a car door panel with 1 meter of length and breadth of 0.5 meter and a thickness of 2 millimeter, the essentially plate that is being used here, and the loading, let's say 360 Newton, half the weight of a person. As you can see, we directly get a minimum for the yield strength that students can essentially sorry, use this value when they are running material selection projects as essentially a screening tool, so that any material that has essentially a yield strength lower than this value would be eliminated from the pool of materials that they're considering. So as mentioned, it translates engineering requirements into material properties. And of course, if we put in something for the maximum deflection, then the software would provide us a value for minimum Young's modulus as well. Okay, so that was the engineering solver. Let's go back to the slides and talk a little bit more about simulation. So of course, as you may have noticed, in the recent years, the role of simulation in engineering education has been becoming essentially more prominent. It's the same thing in industry, of course, as well. But you might have noticed that when students are running simulation projects or, within the courses that they are working on, for example, in their coursework, when they are doing simulation, they typically choose to choose to use materials, one or two materials that are on the top of the list of very few materials that are available for them to choose from when they are within a specific simulation software. There might be, I don't know, 10, 15 materials available for them to choose from in that software. They typically choose either the stainless steel or aluminum alloy. And of course, this means that the result of the simulation that they are counting on would not be as accurate compared to real life. So this is where EduPack can be helpful as well. How? Well, students would be able to run material selection projects within EduPack. They can identify the right materials for the application that we have in mind. And then they can essentially export materials data from EduPack into CAD and CAE software that they're using in their projects. They can, of course, create iteration loops in order to further optimize the design of the geometry and also the material that they're using for this application within this loop, so that they would be able to essentially end up with an optimal product. There are different capabilities within EduPack to help with this. For example, there are dedicated exporters to the most commonly used simulation software on the market, and also EduPack is now directly integrated into Ansys Workbench. So if your students are using Ansys, they can essentially directly launch EduPack from the Workbench environment. They can run their selection projects and, of course, link that to the other parts of the simulation that they're running within the Workbench environment. Okay, so let's say a few words about the updates that we have had recent. Apologies. So of course, like any other Ansys solution, we update EduPack twice a year, and at every update, we try to implement the feedback that we have received from the academics that are using EduPack around the world. So, as I mentioned in the beginning, there is a very large community of academics that we are collaborating with, and we try to implement their feedback as much as possible at each release of the software. So I'm just going to talk about some of these recent ones that we have had since 2020. We've of course added new databases and updated existing ones. We added medical devices and the design database in 2020, and we've also updated the architecture database. I've made available a bit more data within that database and restructured its essentially structure so that it is now can be very well used with civil engineering students as well as architecture. So it is now called the built environment, and it's revamped essentially in 2022 release. We added the battery designer tool among other tools recently in 2021. And with this one, students are able to estimate performance of battery packs and battery modules. So if these are the type of subjects or topics that you cover for your students, this tool can be very helpful for this purpose. We have also added more than 100 dedicated data sheets for different types of battery cells at the same time. So this is available in the full edition of the software. If this is interesting and helpful for your courses, let us know, and we can discuss your needs and requirements further. And finally, as mentioned, we try to improve the links between EduPack and simulation at every release. For example, recently we have created essentially dedicated exporters for Ansys Discovery, which is one of the new tools in the Ansys environment for essentially providing easy and fast simulation for students that might not be experts in simulation. This is a very good solution for that purpose, and it's now essentially integrated with links. There are links available between EduPack and Discovery to help with this process as well. Okay, so we talked a bit about the software part of the deal. Let's talk about the teaching resources now for a little bit. Sorry. So as mentioned, there are more than 200 of these on our website. They are categorized into different types. As you can see, we have lecture units, case studies, white papers, exercises, micro projects available. Some of them are in different languages as well. And so please feel free to go on the website using this link, have a browse and see if some of these would be relevant for your courses. They can be extremely helpful. Essentially, this is the feedback that we have got from our collaborating academics. And when they are trying to introduce students to materials or materials-related topics, these would be very helpful resources to get inspiration from, and or also directly used with students as coursework, exercises essentially, and in examinations, project work, and so on. So to give you an example with one of the most popular case studies that we have available on the website, these are a set of interactive case studies that we have available on the website. Within these, students will be able to go through the slides, learn more about materials, attributes, selection of materials, and there are questions within these slides that if students get it right or wrong, the essentially case study would let them know. It also provides them with some information of how they would be able to get to the right answer. For example, if they're deriving a material performance index, it would essentially help them to do so within the slides as well. Apologies. Another type of these resources that are available on the website are complete teaching packages. As you can see, I've included here one that we have for teaching phase diagrams. So as you can see in this teaching package, we have lecture units, concept maps that help academics essentially identify gaps in the understanding of their students of these topics. And there are micro projects to be used as essentially group project work with students. We've also recently created this guide or map to help academics essentially identify which of these 200, more than 200 teaching and learning resources would be relevant for the courses that that the academics are teaching. So I'm pretty sure that Sarah and Erna are going to send some supporting information after the webinar today. This is going to be one of them. So please feel free to browse through and see, if you can identify for different courses, which of these, mostly used teaching resources would be relevant for your course and your students. Other learning resources that are available at Ansys, well, as you might be aware, Ansys has started creating online courses for about 2 years now for different, physics, and we also have one learning track for materials. So if this is something that would be interesting for your students, they can go on our website without registration or payment. It's completely free. They can essentially learn more about material performance, elasticity, structure, and processing of materials using this interactive online course that is available on Ansys website. We also have the Ansys Learning Forum, of course, that is a wealth of information there, hundreds and hundreds of questions about our Ansys solutions, the physics behind the solutions. We also have a dedicated section for materials, as you can see, in which students would be able to interact with their peers, other academics, and also Ansys experts, and they can find out more about using our software or topics that are covered by the software, like material selection. There is a lot of information there and could be used as a self-learning tool as well. So with that said, I'm going to pass over to Sarah to essentially talk about the events that we run regularly, and we can wrap up, and I'll see you at the Q&A session at the end.
Yes,
Sarah?
thank you. So indeed, I hope everything was very clear to you. If not, please put already your questions in the questions bin. Of course, we have a lot of webinars available, not only by us Infinite, but also, of course, by Ansys. These links will be available with the presentation that will be sent to you, but you can also find them directly on the Ansys webinar website. There are also several trainings hosted by Ansys, but of course also by Infinite. Then, as a recap of the webinar of, let's say, Granta EduPack, as Navid explained, it is so much more than just a big database with a lot of material data. But it has all those enclosed tools. It has all those links towards each other, which hopefully you can benefit from during your curriculum or during your courses. Also, when going further to, let's say, master projects or bachelor projects, there is also Granta Selector research available where you can use this specific data to really help your research with that. I think at the end here, yeah. So please, with any question that you might have, contact us. Not only if, of course, you're interested in using Granta EduPack, but also if you have just a question is, can it be beneficial for me? Can it be beneficial for this type of course? Can it be used with, let's say, a smaller student project with just a handful of students? all those things are questions or maybe things or challenges that you where you would like to try out Granta EduPack, please come to us. We of course have our own support team, but Navid is always available also to help us to really educate you on how EduPack can be used the best. So really don't worry to ask any type of question to us. Here you can see, of course, our contact details. So you can either go directly, of course, to our info@infinite email address, but also you can contact me as I am, let's say, in the Netherlands and in Belgium as well. The academic sales overlay. So I will have knowledge of all the academic licenses that are available by Ansys, and will definitely be able to help you with all of your questions. Here is also some links to the academic webinar Ansys startup program. It's a mouthful, but that's another webinar that we Infinite are hosting in September regarding the startup program of Ansys. Goes a little bit further, of course, than let's say academics, but it can be helpful to know that there is, let's say, an in-between program between academics and already the commercial or industrial side of it. Also, the other Granta EduPack webinars and the academic webinar series of Ansys are here available. So with this being said, let's go a little bit into the questions. I see that Frank, you have asked a question regarding the synthesizer tool, and it is the synthesizer tool is not for everyone, same as the solver.
I think Frank is referring to editions of the software.
Yeah, I think so as well. I think everyone can unmute themselves at this moment. So if there's any particular question that you would like to ask live, that's also possible. But please, Navid, please explain where the tools are available in which edition.
Of course. Yes, so essentially the synthesizer tool, the engineering solver, and one or two other tools are, that is correct. They're only available in the full edition of the software. So if you currently have the introductory edition and think that this could be helpful for you, let us know. We can discuss how you can essentially operate the full edition of the software. But yes, these are a bit more advanced tools, which is why we thought that it would essentially make more sense to be available on the full edition of the software as opposed to the introductory one. Yeah.
Okay, thanks.
Okay.
Nice.
Perfect. Then we have some questions that we received prior to the webinar, and the first question is, can we add our own materials data to the EduPack environment?
Yes, absolutely. So of course, even though in level 3 databases, sorry, there are, as I mentioned, there are more than 4,000 materials available, but of course, there are hundreds of thousands of materials. So of course, not every material is currently available here. If you would like to add your own materials into the database for comparison purposes or within material selection projects, you can simply use the tools, add record, material universe, and as you can see, the software would provide you with a blank data sheet. And if students have information about any of these different categories of properties, essentially they can fill in minimum and or maximum, and then by clicking on OK, essentially new data sheet would be added within the software. So you can easily add essentially hundreds of materials that you're working on within your own course, or you would like your students to focus on to the software this way. Yeah.
Okay, perfect. How can EduPack help in teaching phase diagrams?
Phase diagram, yes. So I mentioned this, of course, the fact that we have a teaching package for phase diagrams available on our website, but that teaching package is focusing on a set of tools that are available in the software, which is available both in the introductory and the full edition of the software in both. For that, I need to change my database to the material science and engineering database. So let's do so. There we go. So as you can see, the material science and engineering database includes different sections. One of these sections includes phase diagrams. And in here, we have different tools that would be extremely helpful in teaching new students to essentially different concepts within the phase diagrams. So for example, we can use the lever rule tool, which includes a brief description and simple derivation of the rule. But of course, it includes an interactive tool that students would be able to, calm down in temperature. And we would have in the liquid phase a essentially information box for a composition and weight fraction of the liquid phase. And then when we get to the mushy zone, as you can see, the weight fraction is now calculated using the lever rule. So interactively, students would be able to see how the lever rule actually works in action with the schematic that is on the right-hand side of the table as well. So very visual, very interactive tool to teach students about lever rule. Or the phase, essentially the phases tool that, let's go to iron and carbon phase diagram. Students can hover over this phase diagram. They would be able to see in the schematic on the right-hand side the atomic arrangement in different phases, and they can easily compare that. For example, in this mushy zone, we have the solidification front, as well as the FCC structure of the austenite phase in the left-hand side of the schematic, and the freely mixing atoms in the liquid phase on the right-hand side of the schematic. So students will be able to easily compare, for example, the packing density in austenite and ferrite quite easily. So again, very helpful, very interactive and visual ways to essentially teach students about different concepts in phase diagrams. Yeah, I think that probably covers at least a little bit of it.
Yeah, definitely. Very extensive. Then a final question: can this software support in teaching of additive manufacturing? Also something that is, I think, very
yeah, very trendy, talking about additive manufacturing. I say trendy, no offense. Additive manufacturing is my own expertise. I did my thesis on metallic additive manufacturing, essentially. Yes, EduPack can be used for additive manufacturing for very introductory courses, I would say, at the moment. So if we go to, for example, the browse section, let me go to process universe. These are the different processes that we talked about before. One of these categories is dedicated to additive manufacturing. So as you can see, for different types of additive manufacturing, we have data sheets for, and if we open up some of them, you can see like any other data sheet for processes, we have this information, images, description, schematic, all of that is available. So talking about the different processes used with additive manufacturing is extremely easy to use EduPack for that. I would say if you're interested in getting it into a bit more details when talking about different concepts in additive manufacturing, we do have other simulation software in Ansys that could be extremely helpful. For example, within Workbench or Additive Suite, there are capabilities that would help you teach the relationship between processing parameters and the microstructure of materials, or for example, the stress and distortion that is resulting from the additive manufacturing process, or optimizing the build setup. So all of those is covered by Ansys, and all of them are available in the academic licenses of Ansys as well. So if that is something that you're interested in, again, get in touch with us, with Sarah, with me, and we will be more than happy to provide more information on that as well.
Definitely. Okay, perfect. Well, we're just 5 minutes, let's say, over time.
Yes.
I think it was helpful for everyone. Really, again, don't hesitate to send us any information regarding your challenges or your projects that you're working on. We are very happy to help. Everything will be sent to you later this week or maybe beginning of next week, and also the link to this recording. I thank you, and I wish you, of course, a very good day, and thank you for joining.
Thank you, Sarah. Thank you, everyone. Have a good day.
Have a good day. Bye.
Bye.